Get that going. All righty. And I think we can go ahead and begin. All right, so welcome to an introduction to QGIS. This is the first of 4 sessions. So it'll be every Wednesday this month at 3 o'clock. I am Sarah Cunningham. I'm the Coastal Training Program Coordinator at the Mission Aransas National Estuarine Research Reserve, which is located in Port Aransas, Texas. Some of you might be familiar with the National Estuarine Reserve System, and some of you might not. So we're a system of several reserves around the country that basically just do stewardship and research and education on estuaries. So with that, I'll go ahead and let my colleagues introduce themselves. So I've had the pleasure of working with both of these ladies previously. They both are excellent GIS resources, so I'm very excited. So Jill, if you want to go ahead and take it away.
Yeah, okay, so hi, like Sarah said, my name is Jillian Paulino, and I'm a second-year PhD student at the University of Tennessee, Knoxville, and I'm currently studying civil engineering. My main thesis work right now is on stormwater management, and I'm specifically looking at using regenerative stormwater conveyances, or like basically a series of step pools in order to decrease erosive flows and increase water quality. My previous degree is from the University of Florida, and I got my bachelor's in environmental engineering there. And then while I was in my undergrad, I actually learned Q and taught myself Q through an internship with Mississippi State University. And it was really from that experience of teaching myself Q that I sort of like developed like a passion for learning more about it and also like teaching others. So this is my 3rd workshop of QGIS that I've taught. This is definitely by far the largest one, so it's very exciting. But yeah, so my previous projects working in Q, just to give you an idea of some of the different types of projects and like data that we can analyze and questions we can answer. I've looked at microplastic distribution within the Gulf of Mexico, both like linearly within the water column and also distributed across the Gulf. I've also looked at the different types of coastal restoration projects and their impact on marsh species. So whether or not specific restoration projects increase or decrease or change the location of marsh grass. And then lastly, and like most recently for my PhD project, I've looked at the soil distribution at my watershed. And then based off of the area and location of my soils, I was able to calculate my curve number and subsequently calculate peak flow. And that value in itself is what I'm like driving a lot of my my calculations and like my thesis work on. So it really all started from something I did in Q. So definitely a lot of different projects in the past and a lot of different applications for the software. So Alyssa, do you want to introduce yourself next?
Yeah, sure. Hey y'all, I work at Mississippi State University in Biloxi, where I coordinate the Derelict Trap Reward Program, which is an incentive program for commercial shrimpers here to pick up derelict crab traps. I've worked at Mississippi State since my final semester at USM in 2018. I worked as an intern and now I'm full-time, and I also just finished I'm finishing up my master's in geosciences with MSU, and I have a bachelor's in geography. I started that in 2017, and I've been working with GIS ever since. So projects I've done is mapping the derelict crab traps throughout the Mississippi Sound, and then my thesis work mapping marine debris throughout the Mississippi Sound and surrounding waters, and looking at the impacts it has on commercial shrimpers. So with that, I'll hand it back to Jillian, and I guess we'll get started.
So before we do that, real quick, a little bit of audience participation. So I'm going to launch a poll right now. if y'all want to just tell us real quick your familiarity with GIS and or QGIS. We'll just give that about 20 to 30 seconds, just so we kind of have a feel. So for almost everyone. Okay, so go ahead and stop that. And y'all can see those results. So it looks like most of y'all have at least some experience, and a lot of you have absolutely no experience with QGIS. So that's very exciting, and also good for our instructors to know. So we will stop sharing that. And then also very quickly, we have a Mentee Poll. So if you want to pull out your phones or a separate screen real quick, you go to mentee.com and you type in that code. We're going to do a couple little word clouds. So yeah, this is just kind of to get to know y'all, and then we will also probably be using some of this to generate some GIS maps later. So that will be fun too. Okay, what states? We got Texas, Florida's looking pretty big up there, Mississippi, Maryland, Idaho, very cool, very cool. Alabama, Georgia, Missouri, okay. It's like Florida's definitely taking the lead, which I'm very surprised at, but that's pretty cool. So I see Jill doing a happy dance over there. She's got lots of Florida experience. Okay, go ahead and go to the next one. If you want to tell me now, well, I can get to the next one. There we go. What is your profession? What do you define yourself as? Graduate student, always a good profession. Environmental manager, biologist, educator. Biologist looks like it's taking the lead. Let's see, extension associate, AmeriCorps, biogeochemist, very cool, marine biologist, student, hydrologist, planning specialist, technician, meteorologist, awesome, avian biologist. All right, looks like maybe we're slowing down here a bit. Data scientist. All right, cool. Well, thank y'all so much for participating in that. And so I'll go ahead and exit out of this. And then Jill, I think we are ready to go ahead and start.
Cool, so I will pull up my screen then. There we go. All right. So let me present. Okay, awesome. So first, I figure we'll go through like the main objectives and goals that I hope everybody that is participating in this workshop and watches all of like the videos kind of walks away with. So first and foremost, I hope that you at the very least, sorry about the very loud grandfather clock, but at the very least, I hope that you download and can get QGIS up and running on your computer, pretty basic. But then also I want to walk everybody through how do we bring in data, how do we create our own type of geospatial data, bring that into QGIS, and then how do we go about editing the outlay and how that information is displayed on our screens so that we can start looking at different patterns and different conclusions that we can come about based off of our data. And then once we have data in GIS, we can then start using and operating our tools or plugins. And that's how we're going to be doing some light spatial analysis. So that'll be kind of towards the end of the workshop, is looking at the different types of like basically tools that we have in our toolbox. And lastly, we'll go over how to operate Print Composer. And that'll be the part of GIS that's completely dedicated to getting that final publishable map output. So whether that's a JPEG, a PDF, but finally gathering all of our data together, processing it, making it look nice, finding whatever pattern or information that we can get from our data, and then presenting it in a map output. So it's a little bit of everything, starting from the very basics of GIS and getting to that final pretty map. Okay, so the general layout of the workshop is first, we will, every workshop I'd like to start with a brief amount of discussion. So especially in the next workshops, hopefully we'll be able to come back and have questions about different, the different topics that were covered in the previous workshops, or different hangups on things that you've maybe tried at home since the last time we talked. So then we can work through that together as a group. And then second, we're going to have this lecture, which is where me or Alyssa are going to be going through the new set of information that we're going to cover. We have a 2-hour block, but I have taken many 2 to 3 hour classes in my time in college, and I find that after about an hour, my brain starts to turn off. So I imagine yours probably does too. So I'm going to try and keep lecturing to a maximum of about an hour, and leave the rest to doing either demonstrations or questions and discussion. So really lecture for about an hour and then end with any questions or clarifications. And lastly, I also developed a set of activities for everybody. It's kind of like your homework for the workshop. So every module will have a step list of different activities that you can do in between now, basically, and the next workshop. And they're meant to just allow you to have designated tasks that reinforce the topics that we've been covering. So if you get stuck on those activities, I've already created a series of videos that walk you through all of the steps. But yeah, basically activities are meant to kind of drive in the points of what we're covering during our lecture, and definitely ask questions, discuss. Like Sarah said in the beginning, if you ever have any questions, feel free, raise your hand. You can stop me, type it in the chat, however you want to go about doing that. But definitely let's make this as interactive as possible, especially over Zoom. I know that's a little bit difficult to interact with, but definitely make this as interactive as possible. Okay, so with all of that being said, let's jump into our first module. So this very first workshop is going to be covering just basic operations and overviews of geospatial analysis. So as we begin, let's cover the main topics. So the outline of this workshop is going to be 1, talking about mapping and just what is spatial analysis. Then I'm going to compare QGIS versus ArcGIS. So many people have heard of Arc. I'd say fewer people have even heard of Q, if not used it. It's even more rare. So it's actually super exciting that a lot of you guys haven't actually tinkered with QGIS, but I expect that the people that have worked with GIS have probably worked in Arc. And then we are going to download QGIS, walk through how you would do that. We're then going to kind of switch gears and talk about just what are coordinate reference systems, what are the different types of layers and what those layers mean, what are base maps, and then we'll look at QGIS's general outlay and how it's set up, how to navigate through just the basics of the software. And lastly, we'll end with bringing in some layers into Q. So we're really starting from the very beginning of just what is spatial analysis and moving into uploading data. So a lot to cover today. So spatial analysis. When I first started creating this workshop, I was trying to think of a good definition. So I turned to Wikipedia, the source of all knowledge. And Wikipedia defines spatial analysis as formal techniques which study entities using their topological, geometric, or geographic properties. And so the main driving behind this type of processing and this type of research-related questions is we're looking at trends based off of location. And that's why we turn to maps. We're trying to look for these trends that are based on spatial positions. And when we have spatial data and we start looking at spatial analysis, it allows us to answer a number of different questions that are actually all really interesting. So the first one being, what is at a specific location? So if we have a location of interest, for example, Florida, we can then start to hone in on what exactly is going on at that specific location and try to look for any common threads between our data at that site. Conversely, we can look at a specific condition. For example, if we wanted to look at areas that have had record high temperatures within the last 5 years, that would trim down the number of locations that we're looking at, but we now have a condition in which we're interested in. So these two things kind of play off of one another. So what's going on at a location and what condition is occurring at different locations. And then next, what has changed? I think this question is probably most interesting for me because of it really drives in the day and age in which we're living in. It's just very exciting, especially for GIS in general, because we have access to satellite data almost all the time through Google Earth and Google Maps. That is a network of satellite imaging that anyone can go online and download at any point in time. So from that data, we can look at how things have progressed, even like dating back 50 years, 50 plus years, depending on where you're at and what you're interested in. And an interesting kind of example of that is I used to work in a coastal lab in Florida, and we looked at the east coast of Florida and how the actual beach has eroded over time. And then when we see that like graphical or that like image, we're then able to find out the actual rate of erosion that is occurring over time. So that actually gives us a lot of like quantitative data just based off of pictures and satellite images. So that one's especially cool. And then number 4, kind of similar to 3, what patterns are existing? What is occurring where, and like what, I feel like the patterns themselves are almost like getting us closer to the answers, like what is going on and why. I think of like my microplastic data for that one. So I looked at the distribution of microplastics in the Gulf of Mexico. And then based off of where I was seeing these hot spots, that then makes me start to ask, why is this pattern here? What is driving microplastics being more abundant in certain areas versus others? And then also, like, what can we do about that? So I think there are really interesting driving research questions behind that. And then lastly, you can ask what if. There is a series of like modeling tools that you can utilize with QGIS, specifically in the software package called GRASS. I know in the previous like editions of QGIS, GRASS would just come with the initial download. I'm not quite sure if you have to like go out of your way to download it separately now, or if it still downloads as one big package, but it's an entirely separate software that kind of adds on to Q. And then also you can have the option of writing your own Python code. QGIS is written in Python and allows you the ability to write your own plugins and your own tools. The Python and modeling are probably outside the scope of this class, so it's kind of getting to the edge of where my knowledge lies. But everything above that, we will be talking about and thinking about and trying to like set up these research questions and things that we can answer using Q. Okay, so next we're going to talk about what is QGIS and the pros and cons of Q versus ARC. So QGIS stands for Quantum Geographic Information Systems. It is a most notably free and open source software. So it's great in that regards. And it allows people to create, edit, visualize, analyze, and publish geospatial information. And so this snippet is from the layout of Q. And one of the really great things about QGIS is it accepts a number of different layer formats. So you can upload data in a much more free-flowing and open way than ARC. So you can upload Excel tables and just almost anything into Q, it will accept. Some downsides to Q are that it is a little bit clunkier. There are a number of different buttons, a number of different tools, so it can appear very cluttered. However, like once you understand like the layout and where things are typically oriented, I think it becomes very easy and very like intuitive of how to use and operate it. But for example, if you're uploading a layer in ARC, you just click upload layer. But in Q, you have to go to add layer, and then there's the drop down of every single type of layer you could add. And every single one of those drop downs will give you a different window. So it's a little clunky, a little bit scattered, but overall it's free and open source. And it has a number of different tools that are very parallel and very similar to ARC. So next we have ARC. So the most noticeable thing about ARC is that, one, you have to pay for your subscription, and the basic package for ARC is $800 a year. And the way that the subscriptions work is, so you have your basic package, but then there's also standard and advanced. And with each of these, you gain more access to the software and to the number of tools that you can utilize. And so I had an internship where we only worked really with the advanced tools. So if we didn't upgrade our package all the way to the advanced, we just wouldn't be able to run those tools in the toolbox. So it definitely can be expensive. And I think it's the biggest drawback with ARC is that if you're a smaller lab, or if you are, I don't know, a startup for a type of engineering firm or do consulting, I think that very quickly the paid subscription is a huge downside. But on the other side of that, it's very clean and basic in the sense that one button will do a lot of different things. So like I was saying, one button will upload every single type of layer you could look for. It's very clean, very sleek, very easy to pick up because of that. And there are tons of resources and online forums. The community of ARC is very well established because it's been around a little bit longer. And then you also get access to ArcGIS Online, which is a cloud of information where you can pull data and contribute data. So all of that is kind of like the pros of ARC and why someone might use it. And then, yeah, that's a window of what ARC would look like on the right, and my thesis field site. So you can see my actual stormwater management site, and you can see there are also a lot less tools in the toolbox itself, up above, just because it's more sleek. So that's the difference between ARC and Q. I'll probably keep referring back to ARC for people that have any sort of background in it, and to also just continue to compare the two. The best way I've kind of ever heard about it is, this is kind of before my time, but I've heard of the transition between people used to use SAS. That used to be the main statistical software that people would use, and you'd have to subscribe to use it. But now everybody uses ARC. That's the main program and software for people that are doing that type of information processing. So in my eyes, I feel like there probably will be an up and coming shift from ARC to Q. It'll be really interesting to kind of see if that does happen, and if in general, these software packages turn more open source and free to the public to use. And workshops like this will help encourage that, hopefully. So. All right, so let's go ahead and talk about downloading Q. So if you haven't already, I saw in the chat that people have talked about some of the problems with uploading for Mac. I don't have a Mac, and I've also never had one, so I'm really great that people have already started toggling through and figuring out how to resolve some of those issues. So that's definitely not exactly my strongest suit. But if you haven't downloaded it already, you can just Google QGIS download, and it'll be the first link that pops up. Otherwise, you can also just type in qgis.org, and that will also pop up this website. If you see this image, you're in the right spot, and you can just click download now. As Sarah, I think, has said in a couple different places, I'm going to be using 3.16. I'm totally fine if you use 3.18. It doesn't really matter too much. They are one of the main benefits of the software being open source is that I feel like there's constantly new versions and evolutions of Q coming out. And to give you an example of that, since I started using Q, I think my first version I downloaded was 2. And they do these increments in 0.01s. So every so often, new QGIS versions will come out, and really the only difference is in the different tool packages. I feel like every now and again, you'll try to run a plugin, or you'll try to do some type of analysis, and there's some type of minor bug, but they're constantly getting better. It's constantly improving, and what you're able to do in Q is constantly expanding, which is all super exciting, because the older versions of Q will always work on the newer Q interface. So when you save your project, it'll save with whatever version or code that you were working in. So if I have files from QGIS 2.0, it'll still pull up in this current QGIS software. The only difference will be if I save my files in QGIS 3.16, that won't open if I open up QGIS 2. Like the old stuff can't read the new, but the new stuff can read all of the previous file types. So normally I just save it and leave it until I need to touch it again. So there's no reason to convert all of your files to the newest version every time. Just when you need it, if you ever have older files, know that they're fine and you'll always be able to access them. So QGIS 3.16, 3.18 is totally fine. There isn't a ton of difference between the two. Okay, so very long-winded, but I think we're finally at the beginning of our geospatial topics. So the very first thing I want to cover are coordinate reference systems and map projections. This is really like the foundation of geospatial information. And it really rewinds all the way back to like, I don't know if in grade school you ever had like the orange problem where you have your orange peel, but when you need to make it flat, you run into this problem of what's the best way to peel the orange and what's the most even way in which to do that and accomplish that. And that's the exact same thing that when we're working with geospatial data that we run into. We are trying to make a 3D object 2D, and there are a lot of problems that come along with that. And so the way that we kind of resolve that is through these coordinate reference systems. So this is a way in which to unravel the globe, right? So in this column or row A here, we could do that as a cylinder. And when we unravel the globe, we would see less distortion in the middle areas of the cylinder. But then when we look to the north and south, that's where we'll start to see larger amounts of distortion. So if we know where our data is in the world, then we can start looking and selecting the best way to kind of peel that orange and achieve the least amount of error and assumptions. So coordinate reference systems are super important to understand just so that you don't get errors by unraveling the world in the wrong way. So to kind of expand upon that, for coordinate reference systems, there's two main types. The first being geographic. Geographic is going to keep the globe as a sphere. And so then when it is talking about coordinates within the sphere, it does so based off of degrees. So it's like origin or datum is at like the center of the globe, and you're then working and doing longitude and latitude based off of degrees from the center. And a really common geographic coordinate reference system is WGS 84. That's the one I operate in most often. And I'd say that for most applications, that reference system will be just fine for the majority of processing that you could want. But again, it keeps the Earth as a three-dimensional sphere. The second is projected, and that is when we're starting to flatten out the globe and making something 3D, 2D. And that is demonstrated with this like X and Y grid. And the nice thing about projected is it allows us to keep constant lengths, areas, and angles. So based off of this localized grid that we're taking this snapshot of the world that we're interested in, we can take in this length or area and have it have the least amount of distortion or error or assumptions. And then the most common type of projected coordinate reference system that I use is UTM zones. And the UTM zones are located throughout the globe, right? And so this image on the bottom right-hand side of the screen, that is a, you can see as you move from right to left, the different numbers for the zones change. So if I'm working in data that is located predominantly in Florida, I would use zone 17, where if I'm located in Texas or like central Texas, I would use zone 14. And that change in zone number is going to help keep all of your data as precise as possible. So understanding where your data is located and how you're going to project it into Q is critical. And if you have experience in ARC, you probably understand these concepts already, but that's a really good foundation for anyone to understand, is reference systems are incredibly important when you're starting to look at processing your data. Okay, so now some more just general GIS, but especially for this workshop, just QGIS terms. First, we have our 3 different types of layers or types of information that we can bring into Q. The first 2 being points and lines. These 2 are pretty self-explanatory. So basically, you have individual points or individual lines that all have data associated with each individual, like, not species, but like point, or each individual line will have its own data associated with it. And then we also have polygons, which are basically just like connected lines or areas. It can be any shape, any abstract thing. But the polygons are really great for defining boundaries and area, and that type of information can be associated with them. So, and they can be as big as an entire state. So you could have the entire state of Florida be one polygon, or you can have a polygon being the outline of a specific parcel of land. So any range in size, most associated with area. Lines will allow you to gather information on length, which is really useful and great, especially when you're working with coastlines or any type of really boundary. And then lastly, you have your points. All of these, like I said, the individual members of each layer are going to be stored in an attribute table. So the attribute table is very similar to just like an Excel table, and every row is going to be corresponding to that individual member of the layer. And what's useful about that is, so say in that first line, we see that there's a difference in the B and C column between these 2 points. That allows us to start looking at these trends. So if we can look at, well, this point is located in Florida and has a higher temperature than this point located in Ohio, that gives us very like physical data located spatially. So the attribute table is where all of our different types of quantitative, and you can even do text-based data. So you could have any type of description for that individual point or line or polygon located in the attribute table. And we're going to be working a lot with the attribute tables moving forward. It's a really great tool and way to start basic processing. So we'll cover that more in the next modules. And then lastly, we have raster files. Raster files are a little bit different than the original 3 layers that I've already covered. They are more like pixelated images, and satellite data or drone data especially typically outputs in these raster file types, and they'll be stored as like .tif files. And the really great thing about them is that they are really useful at storing elevation data. And I'd say, like, I can't really think of an example outside of elevation that raster files would be used for, but each individual box would correspond to a different elevation, and then that corresponds into one big cohesive network or image of what the different variations in elevation would be. And once you have your raster file pulled into GIS, then it's really easy to extract lines or polygons from your raster file and be able to start manipulating those layers and figure out, well, what amount of this area is greater than 50 feet above sea level. So raster files give us this other really great piece of the puzzle. Okay. Next, we're going to cover base maps. So base maps allow us to move from having these layers that are uploaded into GIS just kind of free floating in space. And now we can start saying, where is this in the world? You know, so once points are just points on a blank page in GIS until you have your base map. The base map will tell you, oh, these are points in Texas. These aren't just points in the abyss. And something about Q that's really useful and helpful is that they have a huge software database full of base maps. So you would just drop down and import your base map and pick how you want it to look. With Q, you have to kind of go out and find your own. So that's another like pro and con of using Q versus ARC. But the thing about base maps is they are so readily abundant on the internet. There is so much data, especially for like anything GIS out there. So it's really not a huge task to go and find your own. These are 3 websites that I use pretty frequently to gather my base maps. The first one being Natural Earth Data. This is probably the one I push most people towards. It has literally every section of the globe covered, and if you could want a base map on anything, like name it and they have it. The biggest drawback with it, I'd say, is it depends on the resolution of data that you want on whether or not that you use Natural Earth. So it'll show you the entire outline of the US, but if you need the actual divots and variation in your specific stretch of coastline or stretch of state, then you're probably going to want to grab your base map from somewhere a little bit more precise. But for that really large scale data sets, or just to get a general idea of where you're located, Natural Earth is definitely the website. OpenStreetMap works a little bit like Google Earth or Google Maps. You're able to just pull up where in the world you want to be or what you want to look at. And then from there, you're able to download your base map. Pretty straightforward, pretty useful. And then lastly, NOAA. NOAA is a great resource for base maps. And in general, if you just Google what you're interested in, like what part of the world or what type of data, if it's a coastline, if it's bathymetry, whatever, and then have that like base map free, 9 times out of 10, I'd say you'd be able to find it just through a simple Google search. So definitely don't feel intimidated by the fact that you'd have to go out and find your own base map, because they're just very readily available. Okay, so with all of that, we are now actually moving into Q itself. So this is the general outlay of what Q would look like. So in the very center, this is where our map is actually going to be located and where we are toggling through our data. On the left-hand side, and a lot of this is personal preference, right? So I tend to work with Q in a very bare, like bare basic shell of like just general layouts are going to be very minimalistic for me, just because I don't like to have a very cluttered screen and I like to have my map be the largest thing there. But by all means, there are so many other panels that you can pull up and you can find your preference in where you want certain things. But for me personally, I tend to like to have my layers panel on the left-hand side. So that'll show me all of the different files that I have uploaded and working in my map. And then on the right-hand side, I like to have my processing toolbox. So the processing toolbox is something that we're going to cover in later workshops, but that's basically what it sounds like. It's where we keep all of our tools, all of our methods of analyzing our data. And the way that you're going to get to these panels, oops, excuse me, my dog hit my laptop and changed the slide for me. So the way that we're going to open these panels and adjust them is under View, and then Panels, and then you can select which panel you want to look at and where you want it to be positioned. So here I have my layers and my processing toolbox selected. And then from there, I can drag it and place it wherever I want in the actual like realm of like Q. So I could put it anywhere, but I like to have layers on the left, processing toolbox on the right. The only other thing I really think I even remotely like to have open that I don't have open here is the results viewer. That's right under the processing toolbox. That's particularly useful if you're running a bunch of different tools or if you're analyzing a bunch of data, because it'll tell you what tools you've ran most recently, in what order, and where those files have output. So if you are running a tool that outputs like externally of GIS, you'll be able to find where all of that data is stored. But I don't typically have that open unless I'm like doing a lot of processing. Okay, so next we're going to talk about how do we add and bring in layers into GIS. So the easiest way to go about doing that is just to go under Layer, Add Layer, and Add Vector Layer. And adding the vector layer will allow you to bring in any shapefile into Q. So a shapefile is basically going to be the main file type that QGIS accepts. And the biggest thing to remember with this type of file is that it's not just a shapefile. A shapefile gives Q the location of where it's expecting to find a number of different files. And with all of those files, it will be able to bring in and show you the map or data that you're expecting. And those file types that need to be located there are the .dbf, the .shape, and the .shx. Last time I checked, I think there's actually like 6 or 7 different file types that it creates for itself. But if you have those 3 at the very least, you'll be good. And the main reason I bring that up is especially when you're downloading your base maps, I know sometimes people will delete all the extra kind of like junk, but the DBF and the SHX are definitely necessary, and you need all 3 in order to have GIS be able to process and understand what's going on in that layer. So make sure they're all together in the same location, wherever you choose to save that in your computer. And then next, once you have your layer and your shape files imported into GIS, we then get to talk about like this giant cake in the center of the slide. I think this is the easiest way to think about your layers, is that they don't just kind of scatter about, they stack like the layers in a cake. And so if you have your layer list, and basically what I'm trying to say is that the list and order in which you have your layers listed in that panel is very important, because it will stack on top of each other like that cake. So if they're at the bottom, you only see what's available underneath all of the other layers on top. So if you want something to be front and center, you need that to be at the top of your layer list. So here's an example of what I mean by all that. So here on the left, we have the layers panel on the bottom. So you can see the Gulf of Mexico states layer. So that's a polygon layer. And that's that gray area that has Florida mostly shown. And then underneath that is this sample polygon layer. That's a big pink looking square located underneath Florida. And because that sample layer is listed underneath Florida, it is going to load and be viewed physically underneath the Florida layer. And then lastly, we have the Gulf of Mexico bathymetry lines, which are a line layer. So when we look on the right side of the screen, we then bring that sample layer to the top, and now all of a sudden we can see the rest of that polygon, and we can see that there's a lot more to that shape. So depending on what we're most interested in, whether it be the shape of Florida or that sample layer, we can toggle through and bring that layer up or down in the layers list. Okay, and then lastly, I want to talk about uploading CSV data. So CSV data is a comma-separated variable. It is a way in which you can save Excel data. And what's really great about that is you can go and look up the latitude and longitude for different points and create your own Excel table and be able to bring all of that into GIS. And so if you save your Excel file as a .csv, you then are able to just go under layer, add layer. So the exact same way that we brought in the shape files. And instead of doing vector layer, because this isn't a vector layer, this isn't a dot shape, we then select add delimited text layer. And that will bring up this window on the left-hand side of the screen. We're then able to browse and select our file of interest. And then really all we need to do is set our latitude and longitude and our coordinate reference system. So setting our longitude and latitude, you can either just remember that X is longitude and Y is latitude, or if you're really bad at remembering things like that, like I am, I tend to think of that grid area like on the bottom left side of the screen. And so these blue lines are going to be your longitudinal. And in my head, I feel like by default, I think, oh, longitude is up, down, so that must be my Y field, but that's not the case, right? Because as these blue lines progress right, that tells us where on the X axis we're going to be located. So your longitudinal lines will tell you where in the X field you're going to be. Or the same with that red line. That red line is telling you up and down where you're located. Even though it's the X axis, it tells you where you are in the Y field. So it's a little bit backwards from what I always assume, or like what my gut tells me it is. But at the end of the day, you can remember X is longitude, Y is latitude, you'll be golden. If you get it backwards, you'll pretty clearly be able to tell when your points upload on the other side of the globe that you've done something wrong. So definitely no error really if you mess that up. And then lastly, you have to define your coordinate reference system, which, as I was describing in the beginning, is pretty important. I tend to toggle between either doing my geographic or projected reference systems. And WGS 84 is probably the main one I use. QGIS also, as the software keeps getting better and better versions, they do a really good job of recommending based on where or how your longitude and latitude is stored, what projection or what reference system you should be working in. Because like these latitude and longitude values here, those are very clearly not decimal, or those aren't degrees, right? There's only 360 degrees to the sphere. So it wouldn't even recommend you using WGS 84 because it wouldn't know how to process that type of data. So things like that all kind of add to GIS being able to give you default and recommend good reference systems for you as well. Okay, so with all of that, I'm going to toggle into QGIS. Do we have any questions, comments, concerns before I do that? Because otherwise, we can jump in. You can also take a second and breathe.
And y'all can go to, y'all can raise your hand, use the raise hand function, and we can call on you. Or you can put them in the chat.
Yeah. I haven't looked at the chat for a second, so I just wanted to make sure that we're good.
And Nora had a question earlier that Alyssa answered in the comments while we're waiting to see if there's any other questions. Can you turn specific layers invisible? And Alyssa said, yes, you can check or uncheck any layers you have in the contents and layers list. So Jill, I don't know if that was something that you're planning on showing folks, but that'd probably be good to show for Nora.
Yep, yeah, that's a great question. Yeah, Alyssa answered it spot on. As far as these different file types, I don't know exactly just because I haven't even heard of either of them. But I find that at least most file, I don't know if I've ever really found something I can't upload into Q. So I'm going to say as a default, probably. But definitely feel free to toggle through. I'm going to show you how you can just drag in files into Q. And if it is incompatible, it'll tell you. So pretty easy check there. But like I said, most file types, I'd say, I don't know what types wouldn't be compatible with Q. Because you can even upload a general Excel table. It just won't display it spatially because it doesn't have latitude, longitude to orient itself. But it'll take it. And you can see it in the layers panel. It just won't demonstrate. Yeah.
And then I saw a hand from, I believe, Elizabeth Simon, if you want to come off mute, but you lowered it.
Oh. Sorry, I was just gonna say I downloaded like the wrong thing when I went on the website. So, but it's downloaded now. It's fine.
Okay, awesome. Well, glad you got that working. All right, I don't see anything else. So I guess Jill, if you want to go ahead and move into your demo.
Yeah, sweet. So let me see if I can exit out of. Okay, cool. I was wondering how to like get out of my play view for my Chrome. So first thing I'm going to do is just open up my QGIS. So if you have Windows, I just type that in and select it.
Sorry, I'm going to pause you right there, Jill. Also, this is the point. If y'all want to follow along with Jill, that might be useful. If not, then this will be recorded so you can look at it later on. But
so some of the files I'm going to be working with, obviously I've like created previously, but I'll also make sure that we can grab a couple files to do together so that you can do like kind of half of it with me, see me do the other half. A lot of it's just going to be just general concepts, right? So the very first thing is when it pops up, you see this like news tab. This is new with this most recent version of Q, which is actually pretty exciting. They're really trying to push this community, which I think is very interesting and cool. Then what you're going to do is create your first project. So that's just project and new. And that'll get rid of that news like panel that you were seeing in the center. So here we are in QGIS. Like I said, my layers panel is typically on the left. My processing toolbox is typically on my right. Something that I ran into because I just recently upgraded my QGIS version is that you might not see this processing toolbox. And when you go under view and look at your panels, this might not be here, which can feel very concerning at first. But if that is the case for you, what you can do is hop under plugins and click this manage and install plugins button. And the plugins are basically like, the way I view them is like the open source like toolbox. This is where people have written code that accomplish like very specific tasks, and anybody can have access to them. And then there's like these different sections for like invalid plugins, plugins that don't work, old plugins. If you want to download some from the internet, from like sources that other people have written from, you can. So you could download those as zip files and then install them personally. But there's just a ton here. And what we're looking for when we do this is we're going to scroll down to processing. And thankfully it's alphabetized. So once you find that processing box, if it's not checked, go ahead and check it. Because otherwise, so I'll show you what that looks like. If you uncheck it, it disappears. You can't find it. It's essentially like invisible. But then all you have to do is click that check mark once more. You can close your plugin box. And then once again, go under view, panels, and you should see this processing toolbox pop back up. And like I said, we're going to look and learn a little bit more about the toolbox in the next workshop. But for right now, it's really all eyes on the layers window. So the first thing I want to do, let's make sure, okay, those super pressing questions. We're going to first bring in our layer, our very first shapefile layer. And the way that we would do that is under layer, and then add vector layer. And so for most of you, you probably don't have any shapefiles to upload right now, just kind of floating around on your desktop. And for y'all, what we can do kind of together as a group is go on to this Natural Earth Data website. So it's just naturalearthdata.com. And wait for that to load and click on our downloads button. And give that time to load. And once it's up, you'll be able to select based off of the scale that you're most interested in. When I'm ever downloading base maps, I tend to go with large scale just because it gives you the most detail for your map. The only downside to it is it could take longer to download or longer to process, but I've never actually found that to be the case with my laptops or computers. So I guess for the most part, like if you have like a pretty modern computer, it'll probably process pretty quickly, so it won't slow you down too far. But if you find that is the case, you can go to medium or small scale. Okay, so then you have the option of clicking cultural or physical data. Cultural is going to be like where are cities, where are state boundaries. Physical is going to be where is land and where is water. So these more physical features of the globe. So let's go under cultural and download a base map for the United States. I feel like that's a pretty common used file. So here it has a list of different types of base maps that you can download. So there are roads, there are even like airports and like ship ports. There's all sorts of different types of data that's just stored in Natural Earth. So when I say like there is just an immense amount of data out there, all for free too, which is great. So I'm going to download the admin 0 countries file. So just download countries, that top one. And of course, you can do without boundary links if you want. That's totally fine. So once you get that downloading, okay, well, maybe not. I've actually never ran into that before. Maybe let's try download land boundaries. It's probably the exact same.
Jillian, we're all getting that error as we're trying. Our chat box is blowing up.
Perfect. That's awesome. This is probably exactly why my coding professor said never do live demos. Something always explodes. So let me see. Let's maybe try something a little bit more basic, maybe. Let's go to NOAA basemap GIS. See if we can find something quick and easy. This is for ARC. I wonder if, so I have shape files. Let's maybe see if I can drag them into the chat maybe. Let's see if that works for everyone.
Might have to try it. I might have to change settings for you, Jill.
Sorry?
Try uploading it. I might have to change settings so you can put them in the chat.
Okay. So to answer JJ's question, when you bring in your shapefile, you only need to bring in the .shp. But if the DBF and the SHX are in that file location along with it, then you'll run into problems. But when you're actually bringing in the data, you only need to worry about the SHP, which will maybe make more sense in a moment if I can get this up and running. So let me see if I grab, let's do this one. I grab this data and drag it in, maybe not. I downloaded this also earlier. Sarah, I think maybe, no. Yeah, I could drag this all into a Google folder real quick and then share the link with y'all. Let's maybe try that quickly and toggle through that. So under my Google Drive, we'll just drag in one of my old base maps that I've used. And then I will share that with you guys. Cool. So share. I'll drop the link right in with you guys. Ooh, back. Copy link. Here. Try that, everybody. Hopefully that will work. So you're going to need to extract it once you download it because it's a zip file. But
No, it says we need access.
Oh, perfect. Okay, let me change the share file settings.
Or I need access.
I wonder if it's because it's a university. Only people added can open the link. Well, that's ridiculous. I wonder if I drag it.
You should be able to change that setting, Jill, can't you? Go back to the sharing real quick. Hit the little.
Oh, this guy?
Yeah. Oh. Okay.
The only thing I can think of is it's because it's my university.
Okay. Out of idea, sorry. All right. Well, I mean, I guess if you just want to go ahead and just work the stuff off your computer, I don't want to spend too much time on this, but thanks for trying.
Yeah.
Maybe I'll try and download something and share it for everyone, and then we can try it again later.
Yeah, and like likewise, I can try to email Sarah these files directly, and then we can post them somewhere a little bit more public. But on the fly, yeah, I think that probably just move forward. Sorry about that. Okay, so once we went under, kind of rewinding, we were under layer and we added layer. So now this brings up our vector layer box or window. From there, we can browse our laptop and find whatever file of interest that we're wanting to bring in. For me, I'm going to bring in the Gulf of Mexico state file. So this kind of goes back to JJ's question. So I have all of these file types in the same space, right? But when I go to bring it in, I will select the shapefile. I don't think it really matters in the grand scheme of things. I think you could put your DBF file and it would add. Yeah, so like if you pick a different one, it'll add it. I just typically tend to pick the shapefile. So, but as long as all of those file types are together, GIS will find it and locate them all together. Okay, so when I went to upload my vector layer, the first thing Q is going to ask me is what coordinate reference system I want. And the default is going to be this WGS84, which is perfectly fine by me. So I'm going to click OK. And then I'm going to close. And so here, this file is a polygon of the Gulf of Mexico states. So it's the exact same one from the image that we were looking at. The next thing I'm going to add is a layer that is made from an Excel file. So the way I'm going to do that is under Layer, Add Layer, and then the Add Delimited Text Layer tab. So this is a different section, right? And if I'm pulling in a bunch of different files from a bunch of different data types, I can just toggle from this window, right? Or you can go under Layer, Add Layer, and kind of select as you go, but it's just a little bit more tedious that way. So I'm under Delimited Text. And what I'm going to do is browse my computer once more. And what I've done is I've already created a Excel file for this demo. And what I've done in this demo file, I pull it up for you so you can see what's inside of that file, is I have columns for latitude and longitude, which for that I just very arbitrarily picked locations within these different states. And then I have a column specifically for the state name, and then just sample random data, very arbitrary numbers. And so I made this in Excel and saved it as a comma-separated variable. Another thing about CSV files, if you haven't worked with them, is they only save the current sheet in your Excel file. So if you're trying to work with a number of different sheets, make sure you save each of those as individual CSV files. Otherwise, you're going to lose the rest of your data. So it only saves one window. Okay, so now that we've looked at what demo 1 looks like internally, I'm going to select it as my CSV file. And then, like I said, we just have to select where our longitude and latitude is. So which of these columns is related to the X and Y fields. Like I was saying with the CRS, QGIS typically selects these by default for you pretty quickly and you have no problems, so that looks good. And then I have my coordinate reference system, and I'm going to change that to WGS84. So now I'm going to click Add and Close. And so now we see that we can see these demo 1 points on top of our Gulf of Mexico state file. And going back to another question we had, if we select and deselect this checked arrow or checked box, that will make that layer visible and not visible. So it's a really useful feature, especially when you're toggling between a lot of data kind of all in the same location. And also, like I was saying, if I dragged my demo 1 underneath my polygon layer, now all of a sudden I can't see it. But if I turn it off, you can see it's still there. It's just stacked on top of one another. Okay, so one more thing that I want to talk about or show you is that, so let me bring in this Gulf of Mexico state file once more. So let me go under tutorial. So another way that you can bring in data other than doing like the layer add layer is, like I said, you can just take that shape file and drag it in and it will pop up. And with vector layers, it'll just assume your coordinate reference system. However, for the purpose of demonstration, I'm going to change my coordinate reference system to UTM zone 16 north. So remember how I was saying that the projected and geographic toggling between these two is cumbersome or problematic because you have different, those numbers correlate to different points in space now. So I'm going to click OK, and what you're going to find, so what you're going to find is that purple Gulf of Mexico state file, it disappears because it is now somewhere else in the globe. It is reading those coordinates as something else. So I'm not sure if you're able to see the bottom of my GIS screen because my zoom is like right over my area of interest. But the coordinates, let me make it a little smaller so I can see it too. So these coordinates here correspond to where I am in the map view, right? So we have like -90 and 32 roughly. So when I go to this new state layer, I'm going to zoom to the layer. So that was just a right click, zoom to layer. I now see this purple Gulf of Mexico state file again. So it's still here, it's still in my map. But what you find is that the coordinates are now -1 and 0. And that's because it has now interpreted the latitude and longitude of this file differently. It's now trying to unravel the globe and find its location in space in a very different way than what the WGS 84 is doing. So this -91 is somewhere else, right? So if you pick the wrong coordinate reference system, what you'll find is most likely your data just won't be where you think it should be, or it'll be located somewhere else. So if I brought in my delimited text layer data again, right? And so I'm gonna just very quickly toggle through, bring up my demo 1 again. And the only thing I'm gonna do different is instead of doing WGS 84, I'm gonna click that zone 16. This is the same projection that I used on this that purple Gulf of Mexico state file. I'm gonna add it. And what you see is that these points found one another. But if I only had the orange, right? If I only had the orange Gulf of Mexico state file, now these points are just free floating. So these things kind of all correlate together. So if you use the wrong coordinate reference system, odds are you'll be able to very quickly figure that out on your own, because your files will look like they came into space, but there's just nothing around them because it's trying to interpret the latitude and longitude. And it's making assumptions that you don't intend for it to. So I'm going to go ahead and delete these layers. And the way that you do that, and the way that you kind of like toggle through these different settings in the layers, is you just right click over the layer itself, and you're able to duplicate a layer, remove it. You can even move it to the top or bottom. So there's a bunch of different ways to kind of change your view of these layers. So I'm going to remove these 2 layers. Yeah, so, and then right click zoom to layer is also a very useful tool, because it'll bring the edges of that layer to the edge of your map view. So say I did the same thing for demo 1. I'm going to right click on that and zoom to layer. Now it's zoomed in a little bit more because I'm at the edge of that data portrayed in that layer. But yeah, so we have gone over how to bring in vector layers, how to bring in the CSV files. We've looked at a couple different coordinate reference systems and just general layout of the QGIS software. So with that, I'm going to just briefly talk about what the first activity is. So there is a CSV file from the 2010 US Census data, which is also open, like free to the public, you know, like it's open information. So there's just, I can't stress enough, there's just so much information out there that you can manipulate and look at and process that I at least had no idea was just kind of out there for everybody to look at and to interpret. So I took 2010 US Census data, and you will be taking that file, bringing it into GIS. You're then hopefully importing that base map from Natural Earth Data. I will definitely send Sarah the link or the package for that base map, just in case Natural Earth continues to have that problem. Because naturally, of course, that's never happened, but the day of the workshop, it would do that. And then what you're going to do is make sure that the coordinate reference system for both of these files is WGS 84. And then something that you can try to do on your own that we haven't quite talked about yet, but we will go through detail on how to do it, is you're going to trim the base map to only include the states in the table. So the CSV data is only going to be for the Gulf of Mexico states, because, you know, I'm very interested in the Gulf, and also because we don't need to be dealing with 50 plus states. 6 states is fine. So you're going to trim the base map from the 50 states down to just 6, the 6 that we're interested in. So you're going to be creating that file that I was just showing you on your own. And if you have any trouble with doing that, I've already created like tutorial videos walking through each step of how to move from the very beginning of this activity to the very end. Or you can also wait until the end of the next workshop where we're going to be talking a little bit more like how to select and edit layers. But I think it's a good challenge to start toggling through and trying to do that on your own. But with all of that, also, so I assume this link brings you to the activities site, right, Sarah?
Yes, it does.
Yeah, so if you click on that link, you'll be able to find the CSV file for the census data. You'll be able to find the activity 1 recording if you get stuck. Also, feel free to email me and Alyssa if you have any questions in between. And as far as I know, I think I am good. Sarah, do you have anything, or do we have any other pending questions or discussion?
I was going to say, if you and Jill want to put, I'm sorry, if you and Alyssa want to put your email in the chat so folks have that. I don't think I had sent that out to anyone yet. And then we can also take some questions if you want to raise your hand. Sarah Ann says that you have a question. Go ahead.
Yeah, for some reason my raise hand function isn't working. I used the base map that somebody put in, it was like Andrea put in the chat, and I think I kind of got lost in like adding that whenever like you're going through the steps. And when we go to layer, you go add layer, add vector layer, and then it brings up like you choose, it chose that base map that was on my desktop. And then did we need to adjust any of the default settings, or do we just click add?
Yep, we can just click add. You don't, 99% of the time, the default for Q is totally fine. You don't have to mess with it. As like, if you have experience in ARC, like if you mess with the default functions, it's really just to kind of process the data or tweak it right before you add it, but you can do all of that once it's already added. So I'd say just go ahead and add it.
Okay, so I added it and then I click close, and then I see it like on the side in my layers, but my screen is still blank. So how do I actually view it?
Yeah, so what you're going to do is in your layers, you're going to right click on the name of that layer and zoom to layer, and it should pop it up.
I don't have a zoom to layer. It just says show feature count, copy layer, rename layer, duplicate, remove.
Is it a, can you share your screen? Is that possible? Can we let her do that?
Yeah, I was about to. 1 second. Let's see.
I just clicked on one of the random ones that was in that Google.
Yeah.
Okay. Should be able to share your screen now, Sarah Ann. Made you co-host, so don't let the power go to your head.
Are you able to see?
Yeah, so what that is so you see the image next to the layer name, that it almost looks like it's a box, right?
This?
Nope, down a little bit more, the image directly next to the name of the layer. So that tells you that it is a table. It doesn't have any spatial information.
Oh, okay.
So that's where your problem comes from. So it doesn't know where or what's going on with that. But if you want, I could look at like what, if you want to try adding that one more time, we could see if maybe you're just selecting the wrong file.
So I think I downloaded, so let me go back up to that Google Drive. I just downloaded like a random file from that.
Yeah, so if you don't see the like checked box and it's instead that little table, that, like I was saying before, you can upload Excel data and it'll take it, but it just won't show you anything because there's no spatial information or spatial way for it to show you where it's at.
So then with these, are you still able to see my screen?
Mm-hmm. Yep.
So like out of these, which one was I supposed to download?
So you need to download the entire folder because like I was saying, you need that DBF, the SHP, and the SHX. So it's easier to just download the whole thing. But yeah,
Okay.
then we'll be able to do it.
Okay. Perfect. All right, I will get to that. Thank you so much.
Okay, any other questions? Raise your hand. Pop in the chat box. All right, cool. Well, it sounds like we're all budding experts on QGIS. So I guess that does it for this week's lesson. I put the link for the recordings in the chat box, and it's also in that initial email that I sent out to y'all on Monday. So I hope to have this recording up by tomorrow afternoon. It might not be till Friday or even Monday, but I'll do my best. But the CSV file and the activity 1 recording are up there already. So, and then like Jill said, try and do it on your own, but obviously those are there for your help. And yeah, so the next week's session, Jill, what are we talking about next week?
So next week, we are going to be building off of what we just talked about and moving on to like basics of how do we manipulate the data and how do we start doing like some very basic calculations and layer manipulation. So just taking the data that we brought in and doing a little bit more to it so that we can start doing some minor calculations, start doing some minor processing. So yeah, so just building.
Awesome. Cool. So then I guess with that, we are done for the day and we will see you all next week.
What we can do too maybe is, do we want to like have the Google Slides available for them, at least to view so that they have access to that link and everything else?
Yeah.
So we will find a way to get that out to you, if not via email or some way in the chat or whatever.
I'll probably put it on that same website. All the resources from this class from the beginning to the end will be on that website for eternity or until we decide that the internet's not good and we move to the internet 2.0. So that will be there.
Okay. All right. Well, thank you guys for all of your questions. This was really great. So I'll see you, most of you, hopefully all of you next week.
Bye, everyone.
See ya.